Okay, so once again, good morning, everyone. So this will be our second topic for this morning. No, again, as I mentioned, one of the most interesting topic, and I'm looking forward actually that somebody from you during your capstone project be able also to adapt the IoT. No, looking forward. No, because the Internet of Things is a catch-all term for all growing number of electronics and aren't traditional computing devices, no, but are connected to the internet to send data, receive instruction, or both. No, there's an incredibly broad range of things that fall under the umbrella. So, internet-connected smart version of traditional appliances like refrigerator, no, at present, no, naka-remote control na rin yung ref, no? And a light bulbs, no? Pwede na nating i-off. Even nasa ibang place ka, pwede na nating i-off yung main switch natin, ano? Gadgets that could only exist in an internet-enabled work like Alexa-style digital assistants, internet-enabled sensors that are transforming factories, healthcare, transportation, distribution center, and farms, no? The IoT brings the power of the internet, no, data processing and analytics to the real world of physical objects. So for consumers, this means interacting with the global information network without the intermediary of a keyboard and screen. No, many of their everyday objects and appliances can take instruction from the network with minimal human intervention. So again, no, I'm challenging everyone to have an IoT application on your capstone project, no, during your final year. Okay, so to give us more details about the topic, let us all welcome Sir Darwin. Go ahead, sir.
Sure. Good day, everyone. I'm Darwin Lazaro, your speaker for today's topic, the Internet of Things. Internet of Things is the latest and greatest tech trend in the world today. Millions of people have invested their time and energy, space and money to learn a lot and be part of this technology revolution. So let's start to explore IoT. IoT is a network of interconnected devices and objects that communicate with the ability to bidirectionally transfer data over network. Refers to a type of network to connect anything with the internet base on stipulated protocols through information sensing equipment to conduct information exchange and communication in order to achieve smart recognition, positioning, tracing, monitoring, and administration. Connecting everyday things embedded with electronic software and sensors to the internet, enabling them to collect and exchange data. To make the story short, it can convert dumb things to smart things. And being a smart, it can able to communicate and we can able to speak to devices, listen to the devices, and even understand them. We define IoT in three categories. First, people to people. Second, people to machine or machine to people. And third, machine to machine. Uh, Let us look closely sa mga cellphone natin. So, may mga kasama na yan, may mga features, inputs like finger scanner, face recognition, voice activated, or yung si Google, 'di ba? Yung voice lang gamit niya, makakapag-search ka na eh. Gyroscope, GPS, and sample na pagka inano natin yan eh yung light sensor, yung pagkagabi na magdi-dimmer. Yan. And these are the only samples of the inputs or para magiging what we call na part ng IoT. Ito yung pinadadala sa isang IoT platform. Then with the application itself, pagka pagka sinama dito sa mga inputs nito, like bank, for example, fingerprint, yan, yung mga logins, yung mga ganon is part ni IoT. Another example, so meron tayong cellphone. So when we're talking about smart home, smart devices, merong smart lights, smart switches, mag-on and off, smart lock, which yung pwede mo natin i-configure yan dito sa cellphone natin papunta sa bahay. Likewise, si Alexa, mag-voice, ano yan, voice prompt lang yan eh. When you talk about light, switch on and switch off, according sa mismong platform na yun kung paano mo tatawagin yung command para in order to ma-distinguish niya para ipadala dito sa bahay. Iilaw ngayon yan. Then same thing yung aircon. Same thing with the lock. At saka when it comes sa sasakyan, meron na rin tayong gadgets or kaya natin i-monitor kung saan na yung GPS, 'di ba, sa mga head unit. Kaya nating i-monitor kung nasa yung sasakyan. Like GPS tracking system. Si Alexa meron din dito eh. Meron din siyang, pwede nyo din siyang gamitin. It can monitor your speed limit and even yung gas nyo. Kasi ODB2, saksakan nyo lang yan ng isang aparato na Bluetooth, then connected yan mismo sa, sa head unit nyo or smart devices nyo dun, papunta mismo dito sa cellphone nyo, makikita nyo agad yung status nyan. These are the simple, or this is the, ano na naman to, another IoT environment. A world where the real, digital, and the virtual are converging to create smart environments to make energy, transport, cities, and many other areas more intelligent. It's also referred to the general idea of things, especially everyday objects that are readable, recognizable, locatable, addressable through information sensing device, and controllable by internet, irrespective of the communication means. What problems are we trying to solve? Let us give an example sa connected healthcare or the smart health. Once na connected healthcare, either monitoring of condition of patients inside the hospital or in old people's home. So, once na nilagyan natin yan ng mga devices, inputs na connected sa apps, IoT platforms, and then by feedback is magmo-monitor or mag-read ng data Then eventually magre-respond yun eh. Kung ano yung urgent, kung may urgent bang kailangan. Imagine nyo, parang parang nandyan mismo agad yung doktor sa tabi mo or nurses para mag-gets habang ikaw ay natutulog lang eh. So, at first, it provides real-time data na kung anong talaga ah yung readings or kung ano talaga yung kalagayan mo. Diyan natin makikita. Same as physical activities monitoring. Wireless sensor placed across the mattress sensing small motion like breathing and heart rate and large motion caused by tossing and turning during sleep. Kaya niya mag-gather ng data papunta sa smart devices para i-monitor yung patient. So, ginagawa nga niyang yung devices, computer, na smart na yon, 'di ba? Or cellphone, or it's making the devices more smarter. It can provide far superior analytics para for urgent action. Benefits of IoT: efficient resource utilizations, minimizing human effort, which is makikita natin na hindi mo na kailangan tumutok. Kumbaga, a smart device inputs can generally give you the results based on the rules na sinet mo. It save time. So, siyempre, travels, ah kasi real time na rin to eh. Develop of AI through IoT. So, yan na nga, yung programs, magkakaroon na yan ng automatic warning or AI programs na once na reach niya or na-tick niya yun, yung magko-compute na siya ng kanya and then it will send to you. Siyempre, improve security. IoT Pictures. It composed of three. Connect, which can connect virus things to the IoT platform. Analyze, analyze the data collected and use it to build business intelligence. And integrate, integrate various models to improve user interface. Internet of Things is a global infrastructure for the information society, enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technologies. With the Internet of Things, the communication is extended via internet to all the things that surround us. The Internet of Things is much more than machine-to-machine communication. Wireless sensor networks, 2G, 3G, 4G, GSM, GPRS, RFID, Wi-Fi, GPS, microcontroller, microprocessor, etc. These are considered as
Sana hindi mabasag yung
being the
plastic.
enabling technologies to
May
make
plastic kayo
Internet
dyan?
of Things application
Yung
possible.
sinigang ko sa ano.
The Internet of Things is not a single technology, but it is a mixture of different hardware and software technology. The Internet of Things provides solutions based on the integration of information technology, which refers to hardware and software used to store, retrieve, and process data. and communication technology, which include electronic system used for communication between individuals or groups. Enabling technologies can be grouped into three categories. First, technologies that enable things to acquire contextual information. Second, technologies that enable things to process contextual information. And third, technologies to improve security and privacy. The first two categories can be jointly understood as functional building blocks required building intelligence into things, which are indeed the features of differentiate the IoT from the usual internet. The third category is not a functional but rather de facto requirement, without which the penetration of the IoT will be severely reduced. IoT data transfer. Since na-introduce ko na naman sa inyo yung devices and about the IoT, uh, dito ko yung data manipulation, makikita natin. From the device, papadala niya by means of sensor data, events, alarm, device health, papunta sa IoT backend or the IoT platforms. From the IoT platforms, nandyan yung operational efficiency, system monitoring, cost optimization, informed decision making, which is siya yung magde-decide kung or yung tawag dito basta kung ano yung rules, then pabalik sa device, which compose of commands, software read or controls, and so on. Let's talk about the primary building blocks: the devices, the IoT platform, and the external or enterprise system. Let's go with the devices. Devices, kagaya nung kanina natin pinag-uusapan, meron na siyang sensors, gyroscope, or something, face recognition, voice. Sa isang device pa lang yon. What if meron tayong healthcare system na minomonitor yung heartbeat or etc. Then, together with the gateways, padadala niya yung kay IoT platform. Cloud-based, on-premises, open source. And IoT platform is consists of multiple functions, computation, analytics, and preceded by the external system, which is yung CRM, ERF, weather commerce, which is for sila yung nag-monitor. Then, or else, ano, rules, or kung isa-isa sang company, kung ano yung rulings din, ipapadala niya dito pabalik kay devices. So, sa healthcare, si doktor na nakakakita on real time, nakakita ng result or data na galing kay patients, by real time, pwede niya ipadala kay patient yung mga datang na-observe niya. So, if si patient is need to go sa hospital, need babaan yung something na kung ano yung kailangan niya sa health niya, yun yun. So, makikita na natin yung building blocks mismo ni Internet of Things, which ito na yung devices, IoT platform, and external enterprise system. Internet of Things is not a single technology. It's a way of solving problem. It's an ecosystem of lot of technology that are able to solve problem. Let's discuss about its embedded system. Embedded system are the inputs, whether or how it will get the informations or the data, followed by the communications. Either it will use the HTTPS or Bluetooth, then cloud computing. It's cloud or premises like Azure, analytics. These are the where the algorithm take place. Integration. Integration example is API. Then mobility. This is mobile apps, which is been able to get or to interact, and followed by the UI UX, which is the web based. Let's have an example with case study 1, connected healthcare. Kagaya nung pinag-usapan natin kanina, medyo expand lang natin para mas maintindihan natin or as set natin as example. Si patient, then sa opposite side is si healthcare worker. So start tayo kay patient. Si patient, siya yung magmamonitor ng kanyang blood or what, or merong app, Bluetooth na aparato naka-connect mismo kay gateway plus mobile app na uh, isi-sense or sensor yan na i-get niya yung mga temperature or what na makukuha nito ng app na to by means of Bluetooth device, kumbaga device no. Then ito naman si mobile app, which is yung kanina natin na mobility, di ba? Siya yung makikipag-communicate by means of HTTPS, the communication itself. Then, ipabibigay niya yan mismo kay IoT platform, which is magpe-perform yan si analytic platform ng analytics, command and control, API, which is nakikita naman nito ni health support system by means of API. Si healthcare support system, yan yung minomonitor naman ang bawa ni healthcare worker in order to find yung kung ano yung presently na about doon sa patient. So mag-insert yan ng rules or something na kung ano yung dapat. Then pupasok siya ulit kay IoT platform, which is magte-take sila ng command and control, then babalik niya yung kay HTTPS papunta kay mobile app, which is yung mobility nga. Then si mobile app, siya yung kung ano yung binato mo, siyang babalik sa iyo yung result na makikita mo mismo ni patient, in order na sabihin sa kanya relax ka lang or pumunta ka na dito sa ospital, kailangan kitang i-test further. To yung case study 1 as connected healthcare or smart health. Then dito naman tayo sa case study 2, the asset monitoring, which is ako yung company na i-monitor ko lang yung about the smart refrigeration. Yeah, syempre yung lamig niyan, 'di ba? And dito naman is dalawa lang i-monitor niyan dito. The sensor is monitoring the temperature or monitoring the events o kung ilang beses binuksan, sinara yung pintuan ng refrigerant. Then by means of gateway, not necessarily cellphone, gateway, telemetry events, kumbaga ipapadala niya yan kay IoT platform. Data ingestion, rules engine, alerts, notification, command and control. Ito naman, yung rules engine nito is custom to ng bawat ano kung iba-iba kasi ang rulings ng IoT platform pagdating sa rules engine. According yan sa mismong may hawak or company. So, dito naman, binabato naman nito ni IoT platform papunta kay Dictation Admin App. Si ano naman ang merong application dito. Then, pag nakita ni admin, command co-op, i-set natin ng ganito ang temperature. Then, control na mismo, command and control signal, new setting. Kumbaga, babaguhin mismo, automatic na yung settings na nandun sa refrigeration na yun. Nagaling mismo kay Technician Admin App. Ayan ang case study natin. 2. Asset monitoring. IoT data flow. So, based doon sa pinag-aralan natin kanina na building blocks, medyo palawigin lang natin. At first captured, which is the devices. Which is, dito magagather sensors, di ba? Kung ano yung mga data dito ipadadala sa gateway. Kukunin ng gateway or padadala sa gateway. By means of process, under nyan, may HTTP nang gaganap dyan inside. Process, store, analyze, which is composition of kinukompose siya ng blocks ng IoT platforms. Stream ingestion processing, store structured data, unstructured data, then machine learning, big data store and analytic, artificial intelligence, which is nakikita niyo yung mga ginagawa niyang algorithms lahat. So, kino-compute niya na kung ano yung built-in sa program, lahat yan dyan. Then, after nun, may i-visualize pa yan which is the external system na admin portal, apps, or APR. Diyan na yan yung result mismo from the data captured, ipaprocess, then stored, then after analyze, then magbibigay ng final result yan as visual. That's the internet data flow. Let's talk about its architecture. So, going back kanina sa building blocks niya, device, the other two is the IoT platform and the enterprise system and external system. So, as we can see, after gathering the data dito ng device, kukuhain yan gagather yan mismo by Bluetooth ni, ni Bluetooth or gateway. Siya yung nakakonect mismo sa papunta sa internet After nun, HTTPS, by means of HTTPS, and kukunin yan ng data ingestion ng IoT platform. So, stream process, data store, perform siya ng analytics, then kaano siya ng business services or the rules, and integration service, the API visualization. Then enterprise system and external system, siya na yung mag mag-perform or mag-gather ng control pabalik dito kay internet platform. Si IoT platform, which is from the IoT platform pabalik mismo sa device. Mayroon pa tayong hindi natatakal dito na isa sa IoT platform, which is the device management. Ito mismo yung security. Kasi meron din yan security, si device management. Once na hindi niya na-meet yung conditions, ibabalik na siya. Hindi na siya ipaprocess eh. What I mean, hindi siya kumbaga babalik yan, store data, hindi siya mag-store. Kumbaga babalik yan. Kailangan ma-meet niya yung certain security bago siya mag-process in isa integration services. Lahat yan then pabalik sa kanya bago iba to ulit kay devices. Let's have another example. This example of its architecture is same lang din to eh. Parang tinayo lang natin eh. Makita nyo, si device, smart device sensor layer, nandito yan sa part na to. Then followed by network communication layer, follow daw, which composed of gateways, network gateways in yung palabas ng HTTP, yung or by means of HTTP. Well, dito sa service support, application, and support layer, dyan na yan. Yung virtual entity, yung business process modeling, identity management, access control, which is the command and control, and the final layer is the application layer, which is yung nakikita ng mga kanina, ng doktor, enterprise system, external system. Iyan mismo ang architecture ng Internet of Things. The integration of IoT with other technology like cloud computing, machine learning, artificial intelligence. Hindi kompleto ang Internet of Things kung wala nito. So, that's the Internet of Things. References. Sir?
Okay, so to add additional inputs no related to the topic that our presenter discussed no at present no as of today no. Again, as I mentioned earlier, that looking forward no that somebody from you be able to consider no the IoT applications in the coming capstone project no. Of course, there are more than 50 billion of science fictions. No, IoT lore has the vending machine at Carnegie Mellon that was connected to ARPANET no in 1970 no actually. So at first, the technology of course lagged behind the vision. So every internet connected thing needed a processor and means to communicate with other things, preferably, of course, wirelessly. And those factors impose cost and power requirements that made widespread IoT rollouts impractical. So at least until Moore's law caught up in mind, not in ano. So, of course, we just want to know how does the IoT work. So, the basic elements of the IoT are devices that gather data. Broadly speaking, they are internet-connected devices, so they each have an IP address. They range in complexity from autonomous vehicles that hold products around factory floors to simply sensors that monitor the temperature in buildings. They also include personal devices like fitness trackers that monitors the number of steps individual take each day. To make that data useful, it needs to be collected, processed, filtered, and analyzed, each of which can be handled in a variety of ways. Collecting the data is done by transmitting it from the devices to a gathering point. No? Moving the data can be done wirelessly using a range of technologies or on a wired networks. The data can be sent over the internet to a data center or a cloud that has storage and compute power, or the transfer can be staged, no, with intermediary device aggregating the data before sending it along. Processing the data can take place in data centers or cloud, no, but sometimes that's not an option. In the case of critical devices such as shut-offs in industrial settings, the delay of sending data from the device to a remote data center is too great. So the round trip time for sending data, processing it, analyzing it, and returning instructions can take too long. No, it's such cases edge computing can come into play, where a smart edge device can aggregate data, so analyze it and fashion responses if necessary, all within relative close physical distance, thereby reducing delay. Edge devices also have upstream connectivity for sending data to be further processed and stored. Actually, our presenter discussed a lot of example of IoT devices, no? Because essentially, anything that's capable of gathering some information about the physical world and sending it back home can participate in the IoT ecosystem. So smart home appliances at present, no? RFID tags, industrial sensors are a few example. And these sensors can monitor a range of factors, including temperature and pressure in industrial systems, status of critical parts in machinery, patient vital signs, and use of water and electricity, among many, many other possibilities. The entire factory robots can be considered IoT devices, as can autonomous vehicles that move products around industrial setting and warehouses. Other example include fitness, no, wearables, and home security systems. There are also more genetic devices like Raspberry Pi or Arduino that let you build your own IoT endpoints, even though you might think of your smartphone as a pocket-sized computer. It may well also be beaming data about your location in behavior to backend services in very IoT-like ways. No. So, in order to work together, all those devices need to be authenticated. No, this will be the device management. The provisions configured and monitored, as well as patched and updated as necessary. Too often, all this happens within the context of a single vendor's proprietary systems, or it doesn't happen at all, which is even more risky. But the industry is starting to transition to a standard-based device management model, which allow IoT devices actually to interoperate and will ensure that devices aren't orphaned. No? So, the IoT communication standards and protocols. Now, when IoT or IoT gadgets talk to other devices, they can use a wide variety of communication standards and protocols. Many tailored to devices with limited processing capabilities or not much more electrical powers. Now, some of these you've definitely heard of, some devices using Wi-Fi or Bluetooth, for instance, but many more are specialized for the world of IT, like Zigbee, for instance. It is wireless protocol for low power, short distance communication, while message keying telemetry transport is a publish subscribe messaging protocol for devices connected by unreliable or delay-prone networks. No? The increased speed in bandwidth of the coming 5G standards for cellular networks will also benefit IoT through the usage will lag behind ordinary cell phones. No? For many IoT systems, there's a lot of data coming in fast and furious, which has given rise to a new technology category. Edge computing, consisting of all appliances placed relatively close to the IoT devices, fielding the flow of data from them. No, this centralized system for analysis. For instance, imagine a network of dozens of IoT security cameras. Instead of bombarding the building security operation center with simultaneous live streams, edge computing system can analyze the incoming video and only alert the security operation center or the SOC, no, when one of the cameras detects movement. And where does that data go once it's been processed? Well, it might go to your centralized data center, but more often than not, it will end up in the cloud. And the elastic nature of cloud computing is great for IoT scenarios where data might come in intermittently or asynchronously. And many of the big cloud heavy hitters, including Google, Microsoft, and Amazon, have IoT offerings. Now, the IoT platforms, no, the cloud against are trying, or even the cloud giants are trying to sell more than just a place to stash the data your sensors have collected. They're offering full of IoT platform, no, which bundled together much the functionality to coordinate the elements that make up IoT systems. So in essence, an IoT platform serves as middleware that connects the IoT devices and edge gateway with the application. So you use to deal with the IoT data. That said, every platform vendor seems to have a slightly different definition of what an IoT platform is. Better to distance themselves from the competitions. So, how about the IoT in data? As I mentioned earlier, no, there are zettabytes of data being collected by all those IoT devices, funneled through edge gateways and sent to a platform for processing. In many scenarios, this data is the reason IoT has been deployed in the first place. So, by collecting information from sensors in the real world, organizations can make nimble decisions in real time. Oracle, for instance, no, imagines a scenario where people at theme park are encouraged to download an app that offers information about the park. At the same time, the app sends GPS pings back, no, to the park's management to help predict with wait times in lines. With that information, the park can take action in the short term. Of course, by adding more staff to increase the capacity of some attraction, for instance, no. In the long term, no, by learning which rides are the most and least popular at the park. So, excuse, that this decision can be made without human intervention. For example, data gathered from pressure sensors in a chemical factory pipeline could be analyzed by software in an edge device that spots the threat of a pipeline rupture. And that information can trigger a signal to shut valves, avert, no, a spill. No? Now, how about the big data analytics in IoT? So as an example earlier, the theme park example is easy to get your head around, but it is small potatoes compared to many real-world IoT data harvesting operations. Many big data operations use information harvested from IoT devices correlated with other data points to get insight into human behavior. Software advice gives a few examples, including a service from bursts that match coffee brewing information collected from internet-connected coffee makers with social media posts to see if customers are taking about coffee and brands online. Another dynamic, okay, that actually, another dramatic examples came recently when Xmode, no, or the Xmode released a map based on tracking location data of people who partied a spring break in FT Loderial, no? Lauderdale in 2020 actually. So even as the coronavirus pandemic was gaining spread in the US, showing where all those people ended up across the country. So the map was shocking not only because it showed the potential spread of the virus, but also because it illustrated just how closely IoT devices can track us, no? So another issue and concern, of course, is the IoT data and the artificial intelligence. No, the volume of data of data IoT devices can gather is far larger than any human can deal with in a useful way. No, certainly not in a real time. We're already seen that edge computing devices are needed just to make sense of the raw data coming in from the IoT endpoints. And they also need to detect and deal with data that might be just plain wrong, no? So because many IoT providers are offering machine learning and artificial intelligence capabilities to make sense of the collected data, like IBM's Jeopardy's no, winning Watson platform, for instance, can be trained on IoT datasets to produce useful results in the field of predictive maintenance. Analyzing data from drones to distinguish between trivial damage to a bridge and cracks that need attention, for instance. Meanwhile, ARM is working on low-power chips that can provide artificial intelligence capabilities on the IoT endpoints themselves. No? So, business uses for IoT include keeping track of customers, no inventory, and the status of important components. IT for all flags for industries that had been transformed by IoT, like oil and gas. No, isolated drilling sites can be better monitored with IoT sensors than by human intervention. In agriculture, no, granular data about crops growing in fields derived from IoT sensors can be used to increase yields. No, so looking forward that somebody from you using IoT for agriculture, no, related to the granular data, no. Of course, the HVAC, no, the climate control systems across the country can be monitored by manufacturers, and the brick and mortar retail, no, customer can be micro target with offers on their phones as they linger in certain parts of a store. And more generally, enterprise are looking for IoT solutions that can help in 4 areas: energy use, asset tracking, security, and the customer experience. So actually, we have also a consideration when it comes to industrial IoT, no? So the IoT for the industrial IoT is a specific subset of the Internet of Things, made up of connected sensors and instrumentation for machinery in the transport, energy, and industrial sectors. The IIoT or the industrial IoT includes some of the most well-established sectors of the IoT market, including the descendants of some devices that predate, no, the IoT moniker. No, the industrial IoT devices are often longer live, no, than most IoT endpoints, and some remain in service for a decade or more, and as a result may use legacy, no, proprietary protocols and standards that make it difficult to move to modern platforms. No, that is the IoT. For the consumer IoT, the move of IoT device into consumer spaces is more recent but much more visible to ordinary people. Connected devices range from fitness wearables that track our movements to internet-enabled thermometers. No, probably the most prominent IoT product category is the home assistant, such as Amazon Alexa, as our presenter mentioned, and the Google Home. So for the smart homes, consumer can connect to so-called smart home offerings, providing climate and lighting control and security services. Some of the most popular products are Amazon's Ring cameras, which can connect your home with local law enforcement, and the Google Nest smart thermostat. The smart home market is expected to grow to nearly 60 billion US dollar this year. In the Philippines, now, some of the cities, no, looking forward, and they were targeted to be a smart cities, no. The smart cities promise to transform how individual citizens interact with the urban environment, no. The smart city tech is still embryonic, but in theory will eventually help manage traffic, no, public transit, utilities, safety, and more. But because the stakes are also are so high, improvements in security are a must before widespread adoption is possible. How about of course, we need to consider the security and vulnerabilities of IoT. The IoT devices have earned a bad reputation when it comes to insecurity because PCs and smartphones are general use. Computers designed to last for years, no, or for years, no, with complex user-friendly OS, no, that now have automated patching and security features built in. The IoT devices, by contrast, are open basic gadgets with stripped down OS, no, OSs, no. They are designed for individual tasks and minimal human interaction and cannot be patched, monitored, or updated because many IoT devices are ultimately running a version of Linux under the hood with various network port available. They make tempting targets for hackers. Perhaps nothing demonstrated this more than I don't know if you're familiar with Myrai botnet, no, which was created by a teenager telnetting into home security cameras and baby monitors that had easy to guess default password and which ended up launching one of history's largest DDoS attacks. Now, while this situation is improving somewhat, the truth is that IoT transactions are by and large still not secure because enterprise IoT, customers can work to improve their IoT security, but vendors need to make IoT devices more secure and easier to keep secure if they're going to be in the field for any length of time. No? As of today, in the Philippines, we are also more particular on the privacy. No? We are now in the process of a full compliance with the Data Privacy Act of 2012. Of course, no one wants a hacker snooping on a private data. But what if it's the company that sold the gadgets that's doing the spying? Take, for instance, home digital assistants. Recode has a pretty good breakdown on what Amazons and Google can learn about a person. So from connected devices, you're probably not worried about Amazon learning when you turn your lights on and off. But remember, every bit of information goes into a data lake that can help companies produce a surprisingly complete picture of your life. Because the ability of an IoT devices to track a user's location is a particular privacy concern. We need to consider the map of spring breakers potentially carrying coronavirus home, for instance, because location data is in theory anonymized, but the New York Times put together an extensive report showing how, for instance, the data could be used to track the movements of individuals who could later be identified by name. Another incident crossed the line into a failure in operational security. The Strava heat map, no, which shows popular running routes for Fitbit users around the world, accidentally revealed several secret American military bases. So, what we're looking at for IoT? Perhaps the best way to describe IoT today is that it is in its awkward teenage years, bit enough to be important and getting bigger every day, but still immature in many ways. In the short term, we'll hopefully see improved security, more innovation in edge computing technology, and greater collaboration between IT and OT. No? So, what's farther out on the horizon? As the first generation of IoT projects, which mostly came from smaller specialist companies, ages out of use, we might see new rollouts more dominated by industry giants like Google or Amazon based on more open standards. So the big cellular carriers may also gain a foothold. perhaps IoT devices will become so omnipresent that a wireless network can easily be treated as a giant sensor. It will be an exciting technology to watch, the IoT. Okay, so I think that's it for this topic.